So Amiga Ireland is only 4 days away and I am super excited for it. This is the first one for a few years, no thanks to COVID, but we're finally all getting back together down in Athlone. I'll be there along with a bunch of my Amiga systems. In fact, most of them are already packed up and ready to go. But this year I decided I would try and build something at the event. And one project that I have had lying in a box for quite a while is this, the Terrible Fire TF1260. So while this might be quite the ask to try and put together on the Saturday down in Athlone, I think it's only right that we at least give it a go. But before we do go down there, the one thing that I want to try and do now is to fit and program the two CPLDs. It's not the difficulty in fitting them. The programming bit of it, well, anyone who's been watching this channel for a while knows how well I get on with Raspberry Pis and programming things. So from that point of view, I just think it would be easier for me to fit those now here and get them programmed here, while I can have everything easily online and be able to access all the resources I need to do that. So this board, this was ordered a long time ago. I got this at the same time as I got the TF1230, and honestly it could be going back 2 years. So yeah, I have had this lying for quite a while. But like a lot of these projects that I cover here, the whole idea for building this, well, it came from Gadget UK's Discord. A bunch of us got together, did a group buy of the PCBs and the components. As usual, the task for putting the kits together, well, that fell to Sparks UK, who very kindly sorted all of this out for us. If I remember correctly, the boards came from JLC, and the underside of them is more or less fully completed. There are 1, 2, 3 little resistor packs that need to be fitted on the underside, but other than that, it's just the top side that needs to be done. There's all the components that are still yet to be fitted, or well, all the small stuff anyway, and as you can see, there isn't that much of it. We have the two CPLDs to go on there and there. Just 64 megabytes of RAM going onto this card. You can go up to 128 meg, although in the Amiga, and for all I'll be using it for, 64 megabytes is more than enough for me. We obviously have quite a bit of through-hole soldering to do later on. We've got the edge connector to fit the 68K socket. This thing, which was very kindly donated to me by Mark, aka Super Duper. He sent me a 68K socket and an 030 socket. The 030 one you've already seen used on the TF1230. And I suppose part of the reason that I hadn't built this until now is that I've been missing the CPU. That's in here, and sorry to disappoint, but it's not the full fat 060 that we are going to be fitting in here. Rather, it's the LC variant, so it is going to be missing the FPU, but it does have that MMU. And it was just from recent conversation actually on Gadget UK's Discord. I decided it was finally time to build this. Put a comment on that I was looking for the chip, and a user by the name of Cavanos, based out in America, he got in touch and very kindly has sent us this CPU. But that's for later. Socket as well, all that's for later. For now, all I want to do before we load the car up and hit the road for Amiga Ireland, all I want to do is fit the RAM CPLD, the bus CPLD, and get both of them programmed. Both of these are the same part number, XE95288XLs. They're both to be orientated on the board, something like this. You can see a dot on the package there, and there's a corresponding dot on the silk screen, that is pin 1. So just give me a second to orientate them correctly. We'll start with this one here, the RAM CPLD, and then we'll try and get 1 or 2 of the pins tacked down. Okay, I think that's aligned properly. I've just got that little bit of capping tape on it there, just to hold it still. I'll put a bit of flux down in this corner here, just beside pin 1. And let's just try and get those first couple of pins down, and then we'll inspect it again under magnification. We have created the bridge there, but we'll not worry too much about that at the minute. I'm trying to use a different tip on the iron, and I don't know if I like it already. It's more like a wedge tip on this rather than the chisel type tip that I normally use. We'll see how it goes here, but I can see myself switching back out to the chisel style tip fairly quickly. But just let me very quickly check the orientation of this. And so it's not too bad. It maybe has moved a little bit on me. But if I hold it there like that, and if we can just get those couple of pins down on that side, well, that should be it. So I'm not too sure just how well that is coming through on the video, but hopefully you can see that it does look like it's aligned okay. And if it's aligned on that side and aligned on that side, well, the rest of it must be okay as well. So let's just get an awful lot more flux around it. Then we can see about getting the rest of those pins soldered in place. Yeah, I really don't like this tip. Like really don't like that tip. Let me change it out. Right, I've swapped back to the tip that I'm used to using. Let's get a load more flux on this. There is way too much solder on this. And granted, while this tip is huge in comparison, as I said, it's just what I'm used to using. So let's see if we can do this properly now. In fact, there's so much solder down that end of it, I think I'm going to need a bit of wick. Yeah, I don't think it looks too bad, to be honest. So let me bring in the magnification for you. It's maybe not 100% aligned on the pods. The legs, I think, are sitting off to the left hand side of the pods, just looking at it there. But it's not too bad. And I don't see anything shorted or anything. Everything does seem to be stuck down as needed. So I'm happy enough with that side, just to do the other three. Well, all down. I'm pretty happy with it. Certainly looks okay under the magnifying glass. Let's just do that one. Well, that's both of the chips fitted. Now it's time to program them. Now, it does say on the silk screen here, the JTAG programmer does not power the CPLD for programming. The board needs to be powered up. And following a quick discussion with a few guys on Discord, the jury's out as to whether or not it is safe to program this thing using the Raspberry Pi. But I really want to get this done before we go down to Amiga Ireland, so I'm just going to chance it. We're going to power the two CPLDs from the Pi's 3.3 volt. For anyone that's been watching the channel for any time, you'll know this is how I always do it. It's just having that written on the silk screen here, well, just makes me a little bit nervous. But I'm sure it'll be fine. And in fact, there is one way to test that this is working okay. Because if we just jump onto the computer quickly, well, you can see over here, I found this handy little guide for TF1260 firmware upgrade using a Raspberry Pi. Now granted, we're not upgrading the firmware as such, we're writing it there for the first time. But I suppose in many ways it's just the same thing, isn't it? So if we scroll down this, I already have my Raspberry Pi all set up. Under this section, where it talks about wiring things up, it does say that you do not need to connect up 3.3 volts. And this guide is written around having a completed TF1260, having this fitted inside an Amiga 1200 with that 1200 powered on, providing the power. But if we just ignore all that and work our way down to this command here, well, if we type that into the Raspberry Pi, which I am currently connected to here over SSH, and if we stick this into the JTAG header, 3.3 volt connection being at the bottom here, if I hold that there with a little bit of tension on it and we run that command, well, you can see that both of the CPLDs are indeed identified. They are located in positions 0 and 1. 0 being the RAM CPLD, 1 being bus. We need to write them in that order. We're going to write the RAM CPLD first. And so if we scroll on down this wiki, we can see the commands here that we need to enter to do it. So again, just applying a little bit of tension to those cables just to make sure that it's getting good connection. And let's see if this works. Yep, one down. Let's do the other one. Need to change that 0 to a 1. Change RAM to bus. Well, that should be it. Both of them have programmed successfully. We can disconnect that. And that is everything that I want to do now. In fact, the only thing I have left to do is pack all this up and get it into the car. It's still dark out, but most of it's in there. Some of it is in there. And unfortunately the CRT and the 500, well, they'll have to stay behind. And then welcome to my table. That's the EATX. There's my CD32. And around here is where we're going to finish putting together the TF1260. So first thing I want to do is just finish off the bottom side of the board. We have 3 resistor networks to fit. Let's get those down. Moving to the top side of the board then, just want to finish off doing all the rest of the small stuff. There's a few capacitors and a few resistors let's get them on next. The next job I want to tackle then is the 5 buffer chips, but it's just the same process as everything else. Bit of flux on the board, hold the chip in the tweezers, solder down pin 1 of it, just inspect then that it is sitting correct on the pads, and stick the rest of it down. Next up then is the crystal, which goes on there. I'm going to do this slightly different than the rest though. I'm going to tin up the 4 pads first of all, then we will position the crystal, remelt the solder, and hopefully that will stick it in place. Then it's just the RAM, and that's all of the surface mounted stuff. One thing you might be able to tell here is that the lighting in this room wasn't particularly suited to doing fine pitch soldering, and unfortunately we do wind up with a couple of problems, but we'll get to that. And so it's just all the through hole stuff. You'll see there that I have the voltage regulator already installed. Not your typical sort of regulator that you would have on any other boards. This is a separate device, and just so it can provide the current that R1260 is looking for. Now, I initially did have this set up wrong, as we'll see in a minute. There are various jumpers on the bottom of it. I thought you just needed to short the one that you wanted to select. I had 3.3 volt shorted. But no, you also need to cut the adjust trace, as if you don't do that, the voltage output will be low. And as you can see, when I first tested it, well, the voltage was only reading 2.8. I did manage to sort that. I got the voltage up to 3.3 by fixing the voltage regulator, fitted the processor, but unfortunately the card won't work. The Amiga just sits at a black screen, no signs of life, and while on the day I did try to reflow some of the work I had just done, I was quickly running out of time because there was plenty of other things going on. There was a fascinating workshop discussing Amiga and the small web. Rob Smith was also giving a presentation on his floppy disk interface for WinUAE. There were a few interviews on the stage. The highlight of that for me would have been the interview with Ron Nicholson.
The main thing that's interesting about the Amiga is I've worked with many designs in Silicon Valley, several dozen. At various startup companies, half a dozen startup companies, Hewlett-Packard, SGI. Very few of them ever made it to market. Very few of them will you find a mention in the history books, more than, maybe a paragraph in Wikipedia or something like that. What's amazing about the Amiga is not design that the team I was part of worked on. What's amazing about the Amiga is the people here and in this room and in the Amiga community who are still designing new software for a hardware design I started 40 years ago this month.
There was also the annual games competitions. And like always, the event finished in the local pub. And we're finally home. Amiga Ireland is all over for another year, but it was really good to get back to it. It has been 3 years since the last time we were all together in Athlone. I'm already looking forward to next year. Just want to say a quick thank you to all the organisers of the event. Arla, Shane, Rob and everyone else. thank you very much for all the hard work that you put into this. It really was great fun. But the question remains, our TF1260, why doesn't it work? So now that we have this back here and we have some decent lighting above us, I've been taking a look again with the magnifying glass, and I think we might have a few dodgy solder joints. Certainly on the RAM, some of my solder work here doesn't look that great. So I think I'm going to start by trying to reflow that. Now, chatting with Stephen Leary down at the event, you know, the guy who designs these boards, Mr. Terrible Fire. Well, first thing he said I should really do is check if we have a clock at a test point here and at this capacitor. Now, unfortunately, my scope won't go anywhere near the frequencies required to actually read that out accurately. But we do have a pulsing clock on both of those points. So while I can't say for sure that we do have the correct clock available there, I would say it's a fair chance that it is correct. The other thing that Stephen recommended I try is diagram. And yes, that would be a really good idea, wouldn't it? But I actually only have one EEPROM left. I need two to write diagram for the 1200. And short of pulling a ROM out of something else and wiping it again, which I really don't want to have to do, but short of doing that, I don't really have any other option. So before we do go to that extreme, what I want to try quickly is just reflowing the solder joints around the two RAM chips. Because as I said, looking at it with the magnifying glass, a couple of them do look a little bit questionable. I've already done that one, but I think the problematic solder joints are more on this chip, because I did have some difficulty getting those pads in behind that capacitor there, getting those tacked down. So that may well be the problem, but I suppose there's only one way to find out. Okay, RAM is reflowed. Let's see what it does. LED goes bright. Is it booting? We have a Amiga test kit in the drive here. And yes. 68060! It's working! Let's go into the memory test. And there it is, 66 megabytes total. We have 64 here, and obviously the 2 meg of chip RAM. So that's all it was, a bad solder joint. Let's run a memory test. Well, it's been right round there once. It has took it maybe 5 minutes to do that. No errors, no problems, so I'm happy enough just to call it successful. We have a working TF1260. You have no idea how happy I am. But I do just want to turn it off quickly, because while there's not really any heat in the CPU, that CPLD, the bus CPLD, that's kind of toasty. And there is a little bit of heat in the RAM CPLD as well. So I want to add a bit of cooling to this. I have these wee gold looking heat sinks. They are just a bit of painted aluminium, but I think they should do on there. Like that and like that. And then I have this slimline one, which I'm hoping will go on the CPU. To hold those in place and also to provide a bit of thermal transfer, I'm going to be using this GELID, the GP Extreme cutting edge thermal pad, 1mm thick. If I can figure out how to get into it. But it's just a big pad, and we're just going to cut it down, and it'll hopefully hold these things in place. So there it is there. It's not strictly meant to be an adhesive, this, but it is sticky enough that it should hold. our heatsink in place. And if we set the heatsink on, give it a little push, you can see that it does get a pretty decent grip of it. So I don't think that'll go too far. Let's just do the other two as well. Of course, the real test is, does the keyboard still fit? And no, it doesn't. So you'll not be able to see it, but it is hitting off the CPU cooler. As you can see, it has twisted it all out of shape. So that's not going to work. I thought with that being so slim that it might just have done it. Perhaps if we had fit the CPU direct to the accelerator without a socket, then you would have had room for this. Does the keyboard even fit without that heatsink there? I mean, it's bound to, isn't it? Because how many people have a TF1260 by now? And any of the ones I've seen all have sockets. Yeah, that fits okay. And there isn't a lot of clearance in there. I would say the front of the chip, you know, down here where it's closest to the keyboard, I would say there's only 1 or 2 millimeters of clearance. So that might be a problem. Well, it certainly seems at the minute that we're not going to be able to provide additional cooling to that CPU, because I don't have anything that's going to fit. See if I can get my thermal compound back. Anyone who's watching this that has a TF1260, how are you cooling the CPU? Do we just put a fan in somewhere and just have it blow air across it? That would probably be enough, wouldn't it? I don't know how hot the LC chip runs, and certainly at the minute it's only running at 50 megahertz. Now you can push this chip out, potentially all the way to 100 megahertz, in which case I do think it will generate a bit of heat. But if we just leave it as it is for now, if we just leave it at the 50 megahertz, perhaps it'll be okay, just like that. So let's boot into Workbench. Now I have installed the latest 060 and MMU libraries to my 3.9 installation here. Those are required to get this working. Files, apps, has to be a bit of sysinfo, doesn't it? Check it out. CPU 68060. What sort of speed are we getting? 39.25 MIPS, 37,604 dry stones. Yeah, that's pretty awesome, isn't it? Now, of course, with just the LC chip in here, there's no FPU. And you can even see within sysinfo there, it reports FPU NA. Now, on this board, you'll remember that I did fit an FPU here, but this FPU is now disabled, and that's only because there was no option on the 060 to run an external FPU. You either have it in the chip or you don't have it at all. This accelerator then probably won't stay in this 1200. I think I'll put the TF1230 back in here just so that we can make use of this FPU. The 1260 then, I think I'll just put this into my other 1200, and until I can one day get the full chip that does have the FPU in here, well, we are going to be limited in terms of what software we can run, as anything compiled for an 060 in terms of Amiga is more than likely going to be expecting the FPU. Certainly all the 060 demos, I don't think I'll be able to run those. So in reality, the best way to think about a TF1260 with an LC chip in it, the best way to think about this is that it's not an 060 accelerator as such, but rather like a really fast 030 accelerator. It's currently running at 50 megahertz in here, But let's just see how fast it will actually go. So if I browse files, apps, TF tools, you can see that there are 4 tools here created for the TF1260. The only one that we are really interested in is CPU speed. We can use that to change the clock speed of the 060 chip. The other tools there, fan control and light control, well, they don't really apply to my 1260. I don't have a fan connected to it, and my board isn't the one with the lights on it. Speed test, we can run that, and it will try to automatically decide how fast it will run. So let's just try that. You can see it gets up to 75 megahertz there, and that's where it seems to crash. So it failed at 75, but can we change the clock speed to 67? Or well, it's actually 66 point something. But to change it, what we need to do there is run CPU speed equals 67, just 16. Execute, and you can see it has now changed the CPU clock speed to 66.65. Can we run sysinfo again? What sort of performance are we going to get? Well, that is quite the increase, isn't it? Up to 52.34 MIPS and 50,143 dry stones. Now, it did crash when trying to do the speed test at 75. But I wonder if we could push it beyond that. You never know, it might work. Unfortunately, my ribbon cable from this keyboard is starting to fail. It's been in and out of here so many times, just with me working on this machine, that yeah, I think there's maybe a crack in it or something. Need to try and hold it at a certain position to get the whole keyboard working. But let's try and increase our CPU speed. Will we just go all out 100 megahertz? Let's see what that does. Nope. I thought it was working there for a second, but it seems to have crashed. What about 94? That is the next step down from 100. Will this work? Seems to be. Okay, it's not actually 94 megahertz, it's actually 93.75. But running on a 50 megahertz part, that's what, 190% of its rated speed. Will sysinfo run? And check that out, absolutely flying along. 73.62 MIPS. 70,528 dry stones. So I dare say that is possibly as fast as we will get our 68LC 060, and that is definitely more than fast enough. Although until I can manage to get some cooling onto it, well, I think we'll just turn that CPU speed back down to 50, because I don't want to risk the chance of doing any damage here. There is a little bit of heat starting to come there. Let's just drop that clock back down again. And of course, the easiest way to do that is just to reset. Well, there we are, TF1260 built and working. Plus a little trip to Amiga Ireland in the middle of it. It's a bit of a shame that I couldn't get the card working down there. That was my ultimate goal, but I just ran out of time. And it was all just a couple of dodgy solder joints that I had made on those RAM chips. Oh well. Just want to again say a massive thank you to Cabanos for sending me the 060 chip, or should I say Sally Albarak, and sorry if I'm butchering your name there, but thank you very much for sending it to me. Equally, I just want to say thank you as well to Mark Brown, aka Super Duper, for sending me the sockets. The 060 socket that we used in this one, and the 030 socket that we used previously in the TF1260. I do still want to try and get a TF360 for my CD32. I think one of those with that LC chip in it, that would be perfect for the Wii console. But there is also plenty of other things to get done here, so we'll leave that for some date in the future, getting the 360 that is. I haven't forgot about the other Amiga 600, in fact I'm going to try and do that next. But until then, thanks very much for watching. If you enjoyed this video, I would appreciate a big thumbs up. Why not hit subscribe if you haven't done so already? There's still plenty more yet to come here on CRG, and I'll see you next time.